Welcome to another deep dive. And today we're going to be talking about something that's really interesting, at least to me, and that's unsupervised learning,
Oh, yeah, it's a fascinating area.
where computers can teach themselves.
Absolutely. It's one of the, I think, most exciting areas of AI because it really does allow the algorithms to take the driver's seat and sort of sift through data without any predefined answers, looking for those hidden structures and patterns that we may not have even known to look for.
So you're saying, unlike other types of machine learning, where we're feeding it labeled data, here it's just like, hey, here's a pile of data, figure it out.
Exactly, precisely. And it's a lot more in line with how we as humans often learn, right? I mean, think about it. When you were a child, did someone have to explicitly tell you every single little thing, or did you sort of observe and make your own connections?
Yeah, no, that's how I learned everything. I'm completely self-taught.
Exactly. And that's what these unsupervised learning algorithms are trying to do as well. Mimic that same process of observation and sort of inference.
That's amazing. I never thought of it like that. But how do they actually go about finding these hidden patterns?
Well, one common approach is clustering, where the algorithm tries to group similar data points together.
Okay.
So imagine you have a basket of fruit. You've got your apples, your oranges, your bananas.
I got it.
You naturally group them based on their characteristics, right?
Well, yeah,
Yeah.
apples with apples and oranges with oranges.
Exactly. And that's what clustering algorithms try to achieve with data. They're trying to find those natural groupings. So data points that are within a cluster are more similar to each other than to those in other clusters.
So it's like finding the families or the neighborhoods within the data based on their shared traits.
Yeah, that's a good way to put it. One of the most popular clustering methods is called k-means clustering. And so think of it like this. Imagine you're trying to open up a few new stores in a city and you want to optimize their locations. Well, k-means would help you find the optimal spots by analyzing the customer data and finding those central points, those centers of gravity that represent clusters of potential customers.
Oh, okay. So instead of stores, we have data points. And the algorithm is trying to find those central points that act like anchors for each cluster.
Exactly, precisely.
Right.
And then each data point gets assigned to the cluster whose central point it's closest to. And then that's how you form these distinct groups.
Okay, that makes sense. But real-world data is rarely so neatly organized, is it?
Mm.
What happens when those clusters aren't so clear-cut?
That's where things get more complex. I mean, real-world data is messy. You have overlapping clusters, irregular shapes. You really need more sophisticated clustering methods to handle these scenarios. And they use techniques like probability distributions to model the data more accurately.
So it sounds like picking the right clustering algorithm is kind of crucial, depending on the data and what you're hoping to get out of it.
Absolutely, yeah. Another key aspect of unsupervised learning is dimensionality reduction. And this helps us make sense of data sets with a huge number of features, right?
Sure.
So imagine trying to analyze a data set with 1 million data points, each with 1,000 features.
My brain hurts already.
It's overwhelming. So it's kind of like, how do you find the essence of something complex without getting lost in all those details, right? Like if you were to describe a person's face, you don't need 1 million details.
Right.
You just need a few key features: the shape of their eyes, their nose, their mouth.
So dimensionality reduction helps us find those, like the most important features and ignore the rest.
Precisely.
Okay.
And one of the most widely used methods for this is called principal component analysis, or PCA. So think of it like trying to find the main streets of a city, those avenues where most of the action happens. You can ignore those less important side streets and still capture the essential character of the city.
So PCA helps us create this simplified map of the data, highlighting the dimensions that account for the most variation.
Precisely, yeah. And by focusing on those principal components, we can often reduce the complexity of the data significantly without losing too much information.
It's pretty cool how these algorithms can find that balance,
Yeah.
simplifying but not losing too much.
Yeah.
But we've been talking a lot about grouping data and simplifying data. What about discovering hidden patterns, like those relationships that we might not even know to look for?
I mean, that's really one of the most exciting aspects of unsupervised learning, right? Because these algorithms can uncover these underlying relationships in the data without any specific instructions, right? So they're not just organizing information, they're making connections that can lead to new insights.
So they're like little data detectives,
Yeah.
piecing together, clues.
Yeah, it's true. So for example, imagine analyzing gene expression data, right? Where you're looking at which genes are active in different cells under different conditions. Unsupervised learning algorithms can sift through this vast amount of data and find relationships between genes, uncovering connections to specific diseases or even potential drug responses.
Wow, so it's like the algorithm's helping us decode like the language of our own biology.
Exactly.
It's truly remarkable.
And we're only just scratching the surface, you know. One of the most intriguing examples of unsupervised learning tackling a really seemingly human problem is the cocktail party problem.
No, the cocktail party problem, yeah.
Yeah.
Like trying to follow a single conversation in a room full of chatter.
Exactly. It's like, right, our brains are incredibly adept at this, but how do computers even begin to approach this?
Yeah, it feels like magic, just tuning out the rest of the world.
Right. And what's mind-blowing is that computers solve this using principles of probability and statistics.
Wait, I always thought those were just for analyzing trends or calculating odds. How do they apply to, like, separating voices?
Well, that's where it gets really interesting because these algorithms can actually listen for patterns in those audio signals, right? Even when they're all jumbled up together.
Huh.
So they analyze the statistical properties of the sound waves and identify those distinct sources based on those subtle differences.
So instead of, like, data points, they're analyzing actual sound waves.
Exactly.
It's like they develop their own form of hearing using math to make sense of sound.
Exactly. They're learning to disentangle those overlapping sounds just like our brains do, but using a completely different approach, which is really fascinating.
That is fascinating. I never thought I'd be this interested in probability and statistics, It's amazing.
Right.
I'm really enjoying this. It really highlights just how different fields can come together to solve really complex problems.
Absolutely. And it really underscores just the surprising sophistication of these unsupervised learning algorithms, right? They're not just about organizing data. They're capable of tackling these challenges that seem almost human-like in their complexity,
It's true. It's true.
But we'll get into that in just a bit. I mean, it makes you wonder, what else can these self-taught computers accomplish?
Yeah, and I feel like we're watching like a scientific revolution unfold in real time.
Absolutely.
As these algorithms are uncovering these patterns that, maybe we missed.
Precisely. We've really only scratched the surface of unsupervised learning's potential. I mean, it's a rapidly evolving field. Constantly new breakthroughs are happening.
And, before the break, we were discussing that cocktail party problem. And you know how computers can separate voices in a crowded room?
Right.
Which is pretty amazing to think about.
It really is. It's like, by trying to replicate this in machines, are we also understanding our own cognitive processes better?
It's like we're learning about ourselves through these digital minds.
Indeed. It's this fascinating interplay between artificial intelligence and our own, quest to understand human intelligence. But let's move beyond, the realm of sound and into something even more profound, knowledge discovery.
Ooh, that's a good one. How can unsupervised learning help us uncover new knowledge? It seems like you need to give it some guidance, some hints about what to look for.
That's the beauty of it. Unsupervised learning can actually lead to scientific breakthroughs by revealing hidden relationships in data that we might never have suspected. It's like having a digital explorer venturing into uncharted territories of data and coming back with these remarkable discoveries.
So it's like they're conducting their own research expeditions, sifting through all this data.
Exactly. So one area where this is proving incredibly valuable is drug discovery. Imagine analyzing these massive data sets of chemical compounds, gene expressions, patient outcomes. The sheer volume of information is just staggering.
It sounds like an incredible task, trying to find a needle in a haystack.
Right. Yet unsupervised learning algorithms are remarkably adept at this task. They can discern patterns. They can see connections that link specific genes to certain diseases. They can predict how different drug compounds might interact with those genes, paving the way for new drug targets, personalized therapies. It's incredible.
So it's like they're helping us decode the language of biology, offering a deeper understanding of ourselves, potentially leading to like life-saving breakthroughs.
Absolutely. And the potential applications extend far beyond medicine. Think about social networks, financial markets, climate data, any field where there's vast amounts of information.
Right.
These algorithms can be used to analyze it.
It's like having this army of research assistants working tirelessly to find all the hidden patterns.
Exactly. It's this incredible...
It's almost like we've bestowed upon computers a sense of curiosity, letting them follow these trails of data.
Right.
wherever they may lead.
And who knows what incredible discoveries are out there waiting for us.
Like, it's really fascinating.
Yeah, but for now, let's shift gears a little bit and talk about something that's become very relevant to all of us, recommendation systems.
Recommendation systems, those algorithms that seem to know us better than we know ourselves sometimes.
Exactly. From suggesting movies to recommending products online, these systems have become so integral to our experience online.
Yeah.
And it's like having a personal shopper that has this almost uncanny ability to anticipate what we want, and unsupervised learning plays a pivotal role in that.
It does. But how do they figure out our tastes? I mean, I don't remember filling out a survey every time I go online, telling them exactly what I like and dislike.
You're right. It's not about us directly feeding them our preferences. It's about the algorithm's ability to infer those preferences from our behavior, our choices, our actions. It's all about recognizing those subtle digital footprints that we leave behind.
So you're saying it's all those seemingly insignificant little clicks and scrolls and, the websites we visit, the things we buy.
Exactly. Exactly. Our browsing history, our purchase patterns, even how much time we spend on a certain website. All of this provides these valuable insights into our interests and habits. The algorithm essentially constructs a model of our digital self,
Huh.
It's like a representation of our tastes and preferences based on our actions.
It's like building a digital portrait of us, but just based on our online activity.
Precisely, and they do this by identifying patterns, right? So, for instance, if you're consistently purchasing books on certain topics or watching movies in a specific genre, the algorithm picks up on these trends and recommends similar items because it anticipates that you'll probably enjoy those as well.
It's like having this silent conversation with us, like, hey, I noticed you seem to like this type of thing. Maybe you'll like this too.
Exactly. And what's even more remarkable is that these systems can also consider the preferences of other users who share similar tastes, even if those similarities aren't immediately apparent.
Wait a minute, hold on. How does the algorithm know who shares my preferences? Like, I don't have like a digital twin label.
That's where the ingenuity of unsupervised learning really comes in, because it can identify these groups of users who exhibit similar patterns of behavior, even without knowing anything about their demographics or explicit preferences.
So they're discovering these digital tribes of like-minded individuals, even if they're, scattered all over the world.
Exactly. And by tapping into the collective wisdom of these digital tribes, the recommendation systems can deliver even more accurate, more personalized suggestions.
It's like the algorithm is saying, hey, other people who like what you like also like this, so maybe you'll like it too.
Exactly. And that's the power of collaborative filtering, right?
Yeah.
It's this technique that leverages the shared preferences of this community to make better recommendations.
It's really quite remarkable to think about how unsupervised learning is connecting us with things that, maybe we wouldn't have found on our own.
Absolutely. It's a testament to the power of these algorithms to really uncover those relationships, those patterns that shape our world.
But I mean, these algorithms are still, relatively new.
Of course.
They're still evolving.
Yeah.
Refining their abilities. Yeah. It's almost like, we've given them a taste of the digital world and they're just running with it.
Indeed. And the field of unsupervised learning is just advancing at such a rapid pace. It's really pushing those boundaries of what computers can do on their own. I mean, the progress in the last few years alone has been incredible.
So where do we go from here then? What does the future hold? What other mysteries are they going to unravel?
Well, that's the exciting part, isn't it? We're really just beginning to glimpse the vast potential of unsupervised learning. As these algorithms become even more sophisticated, as we gather even more data, I mean, the potential applications are limitless.
So what's next? What are some of those like really promising areas of research? What are people buzzing about?
Well, one area that's generating a lot of excitement is the development of even more powerful generative models. So we talked about this earlier with the cocktail party problem, right? But imagine algorithms that could generate realistic images, videos, even entire virtual worlds.
Wait, are we talking about like computers becoming artists or world builders? That sounds like something straight out of like, science fiction.
That might sound fantastical, but the progress has been astounding. I mean, these generative models are learning to capture the underlying structure of this complex data and then use that to create new original content that didn't exist before.
So they're not just analyzing data that's already there. They're actually creating something totally new, something that's never been seen before.
Exactly, precisely. And this has huge implications, for fields like art, design, entertainment, even scientific research. Imagine using these models to create realistic simulations of physical phenomena to help us understand those complex systems.
Wow, so it's like giving computers a spark of creativity, letting them contribute to, like, human endeavors.
Exactly. Another area that's really exciting is the integration of unsupervised learning with other branches of AI, like reinforcement learning and natural language processing.
Okay, now we're getting really fancy. Can you break that down? How can these different AI approaches work together?
Sure. So imagine a robot learning to navigate a complex environment, right? Unsupervised learning could help it identify important features in its surroundings, and then reinforcement learning could guide its actions and help it learn how to achieve certain goals.
Oh, okay. So unsupervised learning is giving the robot, like, the lay of the land, and then reinforcement learning is helping it figure out how to get where it needs to go.
Exactly. Yeah, great analogy. And then natural language processing could allow that robot to understand and respond to human instructions, so it can become more adaptable, more versatile.
It's like we're on the verge of creating machines that are, truly intelligent in a way that we never thought possible.
And that has profound implications for the future of work, automation, even our understanding of what it means to be intelligent.
It's both exciting and a little bit scary, I have to say.
Of course. But one thing is certain. The journey of unsupervised learning has just begun, and it's going to be filled with incredible discoveries.
I think that's a great place to leave it. We've covered so much today, from the basics of unsupervised learning to its potential to, really revolutionize everything.
Yeah, it's been a great conversation.
And if you're as fascinated by unsupervised learning as we are, keep learning, keep asking questions, and stay curious, because there's so much more to come.
Absolutely.
And if you enjoyed today's deep dive, you know what to do. Like, share, subscribe.
And we'll be back soon with another deep dive into a fascinating topic. Until then, keep exploring the world with, open minds and a thirst for knowledge.